Okay, hi everyone. Today we will talk about the conformations of acyclic alkane. We said the acyclic meaning the part of the compound with no cycle. Okay, that meaning the compound that don't have a cycle in their structure. The three-dimensional structure of the molecules is called the stereochemistry. Okay, we have two type of the dimensional. We have two-dimensional and we have three-dimensional. For the two-dimensional, like this, okay, this the ethane. Okay, this is the two-dimensional. We have just x, y. It is like if you want to draw a compound on your paper. Okay, on the paper. This the two-dimensional. If we want to convert this compound to the three-dimensional, it will be like that. Look, this the three-dimensional, this the three-dimensional ethane. Okay, uh, and I will give you this. Look to the x, y, z, x, y, z. This is the three-dimensional. We have x, y, z, because the two-dimensional we have just x, y, but the three-dimensional we have x, y, z. And the stereochemistry meaning the position of the atom in the space. Okay, the position of the atom in the space. This atom here and this atom here and this atom, it will be like this behind this atom, or it will be in front of this atom. That meaning the position of the atoms in the space. This is the stereochemistry. Okay, this is the stereochemistry. And a model of ethane shows that rotation can occur around the central carbon-carbon sigma bond. Okay, that meaning he said between this carbon-carbon we have sigma bond, single bond. That meaning the rotation, it will be happened then this group here on the up, but if you rotate 100 degree, it will be on the down. Okay, it will be on the down. Okay, that meaning this part here, it will be rotate, or it will be spin, but this part, it will be stable. Okay, you have to remove to move or to rotate one side, just one side of the compound, not both of them. Okay, um, this, he said here that CH3 groups of the ethane rotate, okay, allowing the hydrogen on the one carbon on one of the carbon to adopt different orientation relative to the hydrogen on the other carbon. That meaning this hydrogen here near from this hydrogen, both of them in the up, okay, in the upper side. But if you rotate here, it will be down. Now this down, but this in the upper side. This is the different. It will be give you different orientation. Okay, different orientation before the rotation. And this arrangement are called conformation. This the different positions of the atom. It will be called conformation. Okay, conformations. The conformation are different arrangement of atoms that are interconverted by rotation about single bond. طلبة, this is important. Single bond, not the double or the triple, just for the single bond. Okay, for the acyclic alkane, we said here cyclic alkane, not alkene. Why? Because the alkene and alkyne, there is no rotation, but the alkane, yes, we have rotation for the single bond, for the sigma bond. Names are given to two different arrangements. In eclipse conformation, we say that meaning that the first type of the conformation he called the eclipsed. The carbon-hydrogen bond on one carbon are directly aligned with the carbon-hydrogen bond on the adjacent carbon. That meaning, if you look to this carbon-hydrogen, this bond is directly in the same direction for this, the second carbon hydrogen bond. Okay, directly in the same direction. Okay, يعني directly aligned in the same exactly behind this bond. Okay, both of them in the same side. Look, this in the this side, also this in this side. Okay, also this conformation called eclipsed. Okay, but if you rotate this, just this the hydrogen 60, yani all this group 60 degrees, this hydrogen to become to here. Okay, that meaning we will have different conformation. Okay, this conformation, it will be called Stigart conformation. In the Stigart conformation, the bonds on one carbon biases the hydrogen, look, the hydrogen carbon hydrogen bond angle on the adjacent carbon. Okay, exactly this carbon hydrogen, it will be the direction, it will be between the angle of this carbon hydrogen carbon bond. Okay, it's not in the same direction. Okay, it will be between of them, this if you look from this side. Okay, if you look from this side to the back, that meaning we have two types. We have eclipse and we have the Stigart. This is the eclipse, this is the Stigart. Then the rotation the atoms, or the rotating the atoms on one carbon by 60 degree convert the eclipse conformation into the Stigart conformation, and the Stigart it will be eclipse, and the eclipse it will be Stigart, like that. These conformations are often viewed an end-on that is looking directly down to the carbon-carbon bond. Okay, and if you look from here to this carbon and down to this carbon, okay, you look from this side on both of the carbon-carbon bond. Okay, and on representation for the conformation are commonly drawn using the convention called Newman projection. Okay, Newman projection. The Newman projection said we will be look from this carbon to this carbon to the second carbon directly. Look directly down to the carbon-carbon bond and on. That okay, that meaning you will be look from here. Okay, and draw cycle with a dot in the center to the representation the carbon-carbon bond. Then what he mean here? He mean if you look from this side to this carbon and back to this carbon, that meaning this carbon, the first carbon, it will be like point. Okay, dot point. Look to this. We have a point here in the center. And the behind carbon in the back side, the carbon in the back side, it will be cycle. Okay, it will be cycle. And then we will put the hydrogen. We will put the hydrogen. And this is the Newman projection. Okay. Where is the next slide? We put the hydrogen. We have this carbon, the point in the center, we have 3 hydrogen, and this we have 3 hydrogen. That meaning this conformation now is the Stigart conformation. Why? Because this, it is not directly to this group. Okay, we have different. Then draw the bonds on the front carbon. This is the carbon as a 3-line meeting at the center of the cyclic. Look, this is 3-line. This meeting in the center, in this point. Okay, and draw the bond in the back carbon. This is the back carbon as a 3-line coming out of the edge of the cycle. Okay, 3 lines. It will be meet on the cycle. Okay, on the cycle. على محيط الدائرة. Okay, now step number 3. Add the atoms on each bond. Okay, we have what we have here on the front carbon. We have 3 hydrogen. 1, 2, 3 hydrogen. On the back carbon, this is the cycle. We have also 3 hydrogen. 1, 2, 3. Okay, this is the Stigart conformation. If we rotate just 60 degree, all this 3 carbon together 60 degree, what will be give you the eclipse conformation. Okay, that now this is the Stigart, this is the eclipse. Okay, that meaning a new projection is the representation of the conformation by 2-dimensional. Now this 2-dimensional, this is 3-dimensional, this 2-dimensional, this is a 3-dimensional representation. Okay, because the 3-dimensional representation, it is slightly difficult to explain on the paper or to draw the compound by 3-dimensional on the paper. Okay, if you have big structure, it is so difficult to draw the 3-dimensional representation for the eclipse and Stigart on the paper. Okay, for this reason we will convert the Newman projection. It is method to convert the three-dimensional representation to the two-dimensional representation. Okay, and here he give you example. We have a propane, methane, ethane, propane. He want to make the numeral projection for this carbon, the first and the second. Okay, that meaning the first carbon it will be like point, and we have 3 hydrogen on the first carbon, 1, 2, 3 hydrogen. The second carbon it will be cycle, cycle, and it will be 2 hydrogen and 1 CH3. This 2 hydrogen, 2 hydrogen and CH3. Okay, this is the Newman projection. Okay, now this is a staggered or eclipsed? No, it will be staggered. Okay, because the bond it is not directly to the behind to the bonds on the backside. Okay, now this if you rotate this 3 group 60 degree, it will be give you eclipsed. Okay, and if you rotate the eclipse to the 60 degree, it will be give you again the staggered to the eclipse and the eclipse to the staggered. Okay, now take the conformation of the butane. Okay, he want the butane. We have 4 carbon: methane, ethane, propane, butane. He want the conformation for the carbon number 2 and the carbon number 3. Okay, take the first carbon as a point and the second carbon will be the cycle, and draw the compound. Okay, for this reason, look, this it will be point and this it will be cycle. The first carbon we have 2 hydrogen and CH3, and the second carbon we have 2 hydrogen CH3. Okay, this is the staggered. Okay, the staggered. If you rotate 60 degree, it will be give you eclipse. If you rotate 60 degree, if you give you staggered. Okay, 60 degree again eclipse. 60 degree it will be give you staggered, and then the staggered it will be give you eclipse, and the eclipse again it will be give you a staggered. Okay, here the staggered, if you have different group here like this CH3, not all of them is hydrogen. That meaning we have another group, not just the hydrogen. If the CH3 group, okay, it is directly to the each other, it will be anti. Okay, this on the up and this in the down, it will be anti. Okay, this is normal eclipse. This is staggered couch meaning the CH3 is near from the CH3. Okay, it will be staggered couch. And if you have a CH3 near exactly to the CH3, it will be normal eclipse. Okay, and also it will be give you couch again, staggered couch and eclipse, and it will be like that. That meaning for the staggered we have anti-couch. Okay, but the eclipse, no, just eclipse. This you have to try to draw this on the papers 2-3 times to give you a good idea about the eclipse and the staggered. Now to preparation of the alkane compound. The alkane compound can be prepared from the alkene by using hydrogenation. Hydrogenation meaning increase the hydrogen atoms, on the compound. Okay, if you have alkene, you will be added hydrogen molecule by using catalyst. The catalyst may be palladium, platinum, or the nickel. Okay, to give you saturated. From the unsaturated alkene give you saturated alkane. Okay, this is the first method to prepare the alkane compound. Okay, the second procedure is the reduction of the alkyl halide. Okay, the reduction of the alkyl halide. Okay, the first method is the hydrolysis of the Grignard reagent. Okay, what is the Grignard reagent? Grignard reagent has general formula R. يعني طلبة alkyl group CH3, CH2, CH3 like that. R MgX magnesium and the halogen, and the general name is the alkyl magnesium. Okay, now you have alkyl halide plus magnesium in a solvent, dry ether, it is just solvent. Then it will be give you this complex alkyl magnesium halide. Okay, that meaning this magnesium it will become between the alkyl and the halide. Okay, now if you prepare the Grignard reagent, you go to the step of the hydrolysis for the Grignard reagent with the H2O to give you the alkane. Then it reacts with inorganic compounds including H2O, also the CO2, also the oxygen. Okay, carbon dioxide with the oxygen, and many organic compounds. That meaning, if you prepare the green reagent, then it is easily to give you the alkane by the hydrolysis with the water, with the H2O. Okay, and give you MgOHX. It is just a side product. This the first one. Look to this. RMGX NH3. Also, we can use it. It will be give you also the alkane, and this MgNH2X. It is just side product. Okay. You can use also the alcohol instead of the water, also to give you the alkane. Look to this example, CH3, CH2, Cl magnesium. That means the magnesium it will become between the alkyl group and the Cl to give you green reagent. The green reagent will be hydrolysis to give you the alkane compound. Look to the overall process. Overall process replace the halogen with the hydrogen. Okay, the halogen with the hydrogen. Overall process. Okay, is the same thing for this example. The Mg to give you reaction this compound with the Mg to give you green reagent hydrolysis to give you the compound. The second procedure is the reduction by metal and acid. Okay, reduction. Reduction, what meaning reduction? Or again, reduction is increase the hydrogen atom. Okay, look, we will be remove the Br and put the hydrogen. Okay, with the acid, that meaning we have a proton, the acid here. Look to the HH plus, that meaning this acid proton, and the zinc is metal here, and we have the halogen, replacing the halogen with the hydrogen. Okay, this the second method is the reduction by the metal and acid. Now we will finish from the preparation of the alkane. Now the reaction of alkane. Okay, that meaning if you have alkane compound it is useful to prepare any compounds. It's useful to enter any reaction. This is the meaning for the reaction of alkane. Okay. Now the halogenation. The first reaction of the alkane is the halogenation. The halogenation in the presence of the light or heat. Look, of the light or heat. It is important. طلبة, of the light or heat. Alkane reacted with halogen. يعني alkane with halogen without heat or light, there is no reaction. Okay. Then the important thing is it is present for the light or heat. The alkane react with halogen to form the alkyl halide. This is the alkyl halide. We have alkyl part and with the halogen, the alkyl halide. Okay, that meaning we have alkane with the halogen heating or heat to prepare the alkyl halide. Halogenation is radical substitution reaction. What meaning substitution? Substitution meaning to replace one atom with other. Then here we will take the hydrogen and put the halogen. This is the replacement substitution. Okay, substitution. Radical. What meaning radical? It is some reaction with special intermediate compound with just one electron. Okay, atom with one electron. We have atom without electron positive, yeah, and we have atom with two electron negative, and we have يعني cation anion, and we have radical, the atoms with one electron. This is the radical. And because the halogenation of alkanes is only useful with chlor, okay, with the chlorine or bromine, with the chlor or the brom. Okay, the iodine and the fluor it is not useful. Why? The reaction with the fluor. Okay, why? Because the fluorine is too violent. Okay, it's so reactive, and the reaction with iodine is too slowly. يعني not useful. Maybe need 1 month or 2 weeks to be complete. That meaning this reaction is not useful. Okay, with an alkane that has more than one type of the hydrogen atom, a mixture of the alkyl halide may result. What meaning that? Look, with an alkane with more than hydrogen atom types. Okay, that meaning you don't have just one type of hydrogen. We have maybe primary hydrogen, you have secondary hydrogen, you have tertiary hydrogen in the same compound. In this case, it will give you mixture. Okay, mixture product, not just one product for this reaction. Okay, look to this. Here in the methane gas, all the hydrogen is primary hydrogen. Or okay, all this hydrogen is normal hydrogen. That meaning if you replace this hydrogen, this hydrogen, this hydrogen, this hydrogen, no different. Okay, with chlorine, heat or light, it will be give you okay methyl chloride. Okay, methyl chloride and HCl. Look to this. Cyclohexane, all the hydrogen is the same. If you replace this hydrogen, this hydrogen, this hydrogen, no different. Okay, replaced by brom, it will be give you cyclohexyl bromide. Okay, or bromocyclohexane. Look to this. We have CH3, CH2, CH3. This is the primary hydrogen here. The hydrogen, the three hydrogen here, all of them is primary. Here, no, we have secondary hydrogen. Here we have also primary hydrogen. If you replace this hydrogen, it will give you this compound. If you replace this hydrogen from the middle, it will give you this compound. That meaning we have mixture product. We have not just one product. Here we have one product. Here we have one product. But here we have mixture of product if you're starting compound with more than one type of the hydrogen. Okay, for the excess halogenation, look, CH3 for the excess halogenation, CH4 give you CH3 Cl2. Again, another step of the reaction give you CH2 Cl2. Another replacement give you CHCl3 because the final hydrogen, another replacement, another substitution give you CCl4. This CCl4 we have further halogenation? No. Why? Because the hydrogen is finished. Okay, the mechanism of the halogenation. Mechanism meaning the way how the starting material give you the product. Okay, how the starting material give you the product by any way. Okay, now three facts about the halogenation suggest that the mechanism involves radical, not ionic intermediates. Okay, well, number one, light or heat is necessary. This number one, okay, for the reaction, but because without light or heat, there is no radicals. Okay, number two, the oxygen inhibit the reaction. Okay, that meaning without oxygen in the closed system, if you make your reaction, for example, in the round, okay, inside the round, that meaning this round it will be closed. Okay, the system it will be closed for your reaction without oxygen, because the oxygen it will be react with the free radical and your reaction it will be stopped. Okay, number three, no rearrangement are absorbed because radicals don't rearrangement. Okay, that meaning there is no rearrangement for the atoms. Okay, for the carbocation. Okay, because the free radical is so active, then when the free radical it will be formed directly, it will be entered to the reaction to give you the product. Okay, now a radical is reactive intermediate with single unpaired electron, يعني just with one electron, طلب, with single unpaired electron formed by homolysis of the covalent bond. Homolysis, not heterolysis. Okay, homolysis meaning the bond it will be broken equally to the two electrons. Okay, to the two electrons for each atom. Now the step for the radical halogenation. The chlorination of the ethane illustrates the three distant part of the radical halogenation. Okay, look to this reaction: CH3CH2, CH3CH3Cl2 with heat or light. It will be give you ethyl chloride or chloroethane with the HCl. The first step is the initiation. That means the starting step. Okay, two radicals are formed by homolysis of the sigma bond, and this means to the begin the reaction. The reaction will be started here. Then the first step, two radicals are formed by homolysis of the sigma bond, and this means the reaction. Okay, the reaction will be started. Propagation, the radical react with another reactant. Look, the radical react with another reactant. I will give you examples to form a new sigma bond and another radical. Okay, the termination, the final step or the reaction will be finished. Okay, terminal, two radical combine to form stable compound. Removing radical from the reaction mixture without generation any new radicals to stop the reaction. Okay, now we will give this examples. Look, step number 1, initiation. The sigma bond between chlor and chlor, it will be broken equally. That meaning one electron will be here and one electron will be here. Give you free radicals. This radical with one electron here, one electron. Okay, and also this radical with one electron. This the step number 1. That meaning the heat or the light is necessary for the step number 1 for the initiation step. Step number 2, the propagation. Look, the one of the free radical, it will be react with the static material to give you another free radical, and then the free radical react with another molecular chlorine to give you the product, one molecular product and another free radical. This free radical will be come back here again to react with the starting material and then give you product, and then the radical react with another starting material, give you the product. That meaning the number of your product molecule will be increase. This is the propagation. Okay, and finally the termination. Two free radical, maybe this with this, or this free radical with this, or this free radical with this, combine together to give you a product, and with no excess free radical. That meaning this propagation step, it will be stopped, and the reaction, it will be stopped. This is the mechanism of the free radical reaction. And the chlorination of other alkane. We said if you have alkane with different type of the hydrogen, that meaning it will be give you a mixture product like this. The chlorination of the CH3CH2 afford one to one mixture of this product. Okay, why? Because we have different hydrogen. That meaning if you remove this hydrogen, it will be give you this product. If you remove this hydrogen, it will be give you a product. Okay. And he said has CH3CH2 CH3 has 6 primary hydrogen atoms and only 2 secondary hydrogen atoms. So we have a mixture of the product. And here you have, if you have alkane compound with more substituted group, okay, that meaning for CH3CH increase, look, increase the carbon hydrogen bond strength. That meaning the carbon hydrogen is strong. The bond is strong. That meaning to take this hydrogen is difficult to replace with the halogen. But here is easy to replace the halogen with this hydrogen atom. That meaning this carbon hydrogen bond is not very strong like this. That meaning this compound here on the right side is easy to enter to the halogenation, but this compound on the left side is difficult to enter to the more difficult if you compare these two compounds to enter to the halogenation and to give you the product compound. And again, don't forget that when the alkane react with the chlor, a mixture for product result with more product formed by clip the weaker carbon hydrogen. Anyone is, it will be the weaker carbon hydrogen, what it will be give you the percentage of the product, it will be more than the other. And this chapter is finished already, and next lecture we will be started with chapter 3 inshallah. Keep study again, and if there is any problems, any misunderstanding, any question, we will be meeting inshallah on the model, and see you later. Bye bye.